well, I don't know.
Yeah, so this is the data, right? Keith, is this the data from the balance or from the...
Yeah, so this is data that we collected actually in real user testing with our Balance Interactive.
40 campus.
We like this data because it shows sort of a clear trend, which is definitely one of our goals, was to be able to communicate the overall trend, but also without losing the idea of where am I within this trend and who's close to me, and things like that.
Right. So we have three different types of data here, and we'll walk through these. But we'll start with the first one over here, and we'll go ahead and turn on sound. Everybody hear that clearly? Okay.
So we'll move along the x-axis.
Okay. Just 1 second here, Christina. Sure. X-axis speech is. And you can see on the screen, it's just loading those files.
40.
Just CSV files.
35.
Okay, it looks like on the X right now we don't have speech, but on the Y we do. So just go ahead.
So should I go ahead on the X anyway?
Yeah, we're fine. So I'm just mirroring what Sina does right now, just for the sake of the prototype.
So like if we leave it right there, for example. And then, so on the y-axis, and this should be live. So
5, 10,
okay.
15, 20.
So most likely, there's something there.
There is a big non-speech component.
Yeah.
But the speech helps you with, map it to, the real number space. So it was saying 20, 30, 40.
Exactly.
And so I could be able to say it's between,
Yeah, so point estimation, I can actually tell you where that data point is, and it's like right there, and then we go away from it.
30.
So like right, okay, so we can move X a little bit back, let's say to over here, okay? So you've got my new mouse. And so now, all of a sudden, we can see the different rate map.
40.
And let's come back down.
35. 30.
It's shifting a little bit, so I'm just going to look at Y right now.
Okay, is it locked?
Yep.
Okay, then let's
35.
do this.
40. 25. 10.
And now
We've lost tone. That's
10.
just 1 second.
Out.
Okay.
Left.
Go ahead and try now.
okay. This is why.
Just going to change focus. Right now. Okay.
Out.
And I think that's right.
Okay, that's fine. So just to, what that was going to show is what you would have heard is that that obviously works for every data point. So it doesn't only work for. Oh, we have tone again. Okay, cool. So then thank you.
35.
So then there we go. So let's
50.
this.
10.
You gotta lock me on white.
One direction.
Okay.
10.
Okay, so let's go.
15. 30.
And
35.
that's fine.
Correction.
Oh, just keep it on lock. Keep it on lock. Keep it on lock. Okay, here we go.
40. 35.
Right there. Thereabouts. Okay, so, and that's like between 35 and 40. I wasn't actually ironically paying attention to the speech, but that's because I'm doing a demo. But the neat thing about this is that there's this one-to-one mapping. So on our prototype, the mapping might not be exact just because it was 2 days, but basically underneath is a grid, and so you can get this tactile representation of where you are in position to the data, and then start exploring the rest of the data as well.
Do you want to do trends real quick?
Yeah. So you want to do a trend line?
Yeah.
Okay.
So two major aspects of graph literacy are point estimation and trend analysis. And we've shown some point estimation. We'll just show a little bit of differences between this and some data from the athletic ability that looks a lot different than this, and you can hear some differences.
Do you want to plug in X this time?
Yeah. Just keep going. Oh, yeah. You want to just shift over.
Yeah, you want to shift over to X because for trends.
Yeah.
Yeah. Okay. So you want to switch out nice or?
No. We'll just.
Okay. Cool. Okay. So here we go, and I'm gonna go back to the 0, 0 here. Okay. So now I'm gonna start moving right along the x-axis. And so, as you can see, we're getting different tones. Like there's a low point right there in the graph. Let's keep going. There was a high point followed by a low. This is like and then we can start getting a sense of the data. And because the pitches are mapped across octave boundaries, we can actually get a really clear differentiation between where the different points are. And so, like, there was another low, there's a high, we can keep going to the right here, and we can see some, a little bit of clustering, and then, followed by, like, right now we're on a high note, for example, so we're on a high part of the graph. And so it's a one-to-one mapping to pitch, so you can not only estimate your specific point, but you can start learning about the entire data set. And this obviously, since it's data backed, the data can change dynamically every single minute through the exhibit, and the display can keep up with it.
Should we?
Yeah.
Okay, great. Let's do another type of graph so you can hear the difference. Just pass it.
40.
You want me to zero you out?
Yeah, to zero out.
40.
So that one.
35.
Many of you saw the graph, so you may have been biased, but to me it sounded like it was going up high notes, kind of middle notes, and then high notes. And now we're passing over from left to right.
Okay. So here we go.
We're getting lower notes, high notes, kind of all around.
5.
This is a measure of athletic ability and balance. Why is balance? Right. So you're getting pitches all over the place, which probably means there isn't a trend. There's some sort of noise. I'm sorry. So there's some sort of trend that appears in the first one, but not really in the second.
Right.
Sorry.
So, do you want to talk more about sonification, or should I talk about it?
Well, there's some interesting things we found in this. A lot of the earlier work in sonification is focused on lines and things, and one of the things we found is when we gave resolution to a single node, it was actually a little bit more confusing. So when we reduced, we binned the data a little bit more into octaves. It was much easier to tell where that curve was. That's actually a really interesting finding. So that less resolution actually gives some more of an intuitive sense. What's that? Yeah.
So one of the other things that we found during this was that we have 2 mice, and these can be anything. Like Ben was talking about, any kind of continuous actuator here. It can be a slider, it can be even a joystick where you can have different axes of movement, and like a little D-pad or something. So that's really important because when you have these simultaneous inputs, one of the things we found is that there's not a really good way just on the software side to handle these. So one of the other artifacts that are coming out of this is a library that can weave together, we're tentatively calling it Input Weaver for now, but it can weave together these different kinds of inputs into one thing. So a developer at a museum no longer has to go through these problems of how do I deal with multiple mice, how do I deal with 2 joysticks and 1 button interface like a keyboard and 2 mice. It's just one library that on the software end will give all of these things to you as one stream, and the advantage to that is then something like this is really easy to replicate in the future.